Today we're going to be writing another IA. I love making these videos. I think writing IAs is a lot of fun. So today we are going to be studying the movement of this ballerina here. And I'm using the same trick of putting a timer on top of a video like I explained in the previous IA video. And the idea here is that this should look something like a trigonometric function because her foot is going around her. So it's like left, right, left, right. It goes back and forth. So something that a trigonometric function should be able to do. As we'll see, it's going to be a little bit more complicated than that, but this is the general idea. So the first thing that I needed to do here was the data collection. And one of the variables is very easy. It's time. It's what it says on the timer when I pause the video. But the other variable that I want is the distance between her foot and the axis around which she is spinning. But that is complicated because she's a human being. She's not a robot. So she's not perfectly vertical. She's trying to do the best that she can, and so am I. So what I did here was that I put a vertical line on top of the picture, and I created it with a slider so that I have some freedom to move the vertical line to the left or to the right in each frame that I'm going to study if I need, because the camera also moves a little bit throughout the thing. And I decided that I was always going to align that vertical line with her left foot, the one that is on the ground, the tip of her left foot. Sometimes that also aligns with the middle of her head, which is great, but sometimes it doesn't, and that's it. It's a choice. We have to make a choice. So then after that, I also put another point at the tip of her other foot, the one that is spinning, and then I put a perpendicular line to the vertical one just so that I can measure this horizontal line segment here is going to be the thing that I'm studying, is how this distance changes as time goes by. So whenever her foot is to the right of the vertical line, I'm putting that in my spreadsheet as a positive number. And when it is to the left of the vertical line, I'm putting that in the spreadsheet as a negative number. The video has her spinning around a bunch of times, but I only collected the data for 2 of those spins because I thought that would be enough to make a mathematically interesting IA. So let's go ahead and see what we can do with these numbers. So let's see what we've got here so far. I am naming my IA modeling a fouette with trigonometric functions. And immediately we have a problem, right? Because I didn't know what a fouette was before this. And when I was just explaining it to you just now, I showed you a video, but we don't have that option in the IA. We can't show a video to the reader. Some people ask sometimes if they're allowed to put a link to something that they want the reader to be able to see. And sadly, the answer is no. You can put a link if you want, but nobody's going to click it. Maybe your teacher will click it when she's grading your IA if she wants, but she can't take that into account in your grading. So when we want to describe something like this, it can be very difficult to put into words. So I decided instead to make like a little comic book with screenshots here. I hope this works. I hope the people who only look at this without the video can sort of understand what is going on with the ballerina there. I do have a little description here. She spins around multiple times, and as she does so, her leg also spins around her. That is a very small and poor explanation, so I am really counting on the images speaking for themselves. I did not do a very good job of this comic book here, okay? I took 6 images that are just screenshots from my iPad. Ideally, we wouldn't be looking at the whole bottom of the screen like that. I would have cut them up more. Maybe ignore this blank space to the left so that I could fit maybe 8 pictures instead of 6. There are better ways to do this. And in terms of the rubric, this can count against my organization in rubric A because I didn't do a very good job of making this figure. You will notice what I did do though was put a source under the figure, and right now I have to tell you this is not the actual source of the video because I've had this video in my phone for a long time now, and when I started making the IA I couldn't find the original one anymore, so I just put a link to a different video here just because I wanted to show you how to put the source, okay? The source is a YouTube link, but it's not a clickable link because we are writing a paper, we are not building a website, and the source is right here on the figure. It is not way in the end in a bibliography or something. These are also important organization considerations. Now, what is lacking from my text here is something like, ever since I was a little girl, I've always loved dancing ballet. First of all, that's a lie. I've never danced ballet. Of course, nobody would know if you were lying, so it doesn't matter. But it doesn't matter either way because nobody cares. People tell this kind of story, like ever since I was a little girl, because they imagine that this is what counts as personal engagement for rubric C. This is not true. The ever since I was a little girl stories are only cringe to read. I do not like reading them, so I can skip that. I do need to explain what a fouette is because that's what I'm going to be working with in my IA. But the personal engagement is going to come later, okay? It's going to come throughout the text as I engage with the mathematics that I am using in my IA. It's not a thing about backstory and why you care about your topic. That's not what personal engagement is about at all. So anyway, very important also for organization here is the aim of my investigation is to model the distance between her right foot and the vertical axis around which she is spinning. Hopefully this one sentence explains what we've been talking about before. And then I go on to mention some of the imperfections that I also mentioned before. There are many imperfections in the video, from her performance to the camera, and that means that the measurements will all be approximate. So there is another thing in the rubric, rubric D, reflection. There is a list of possible ways to show reflection, and it talks about considering a limitation. But right here, if you want to show reflection by considering a limitation, do it when it happens. Like, it's a silly limitation in data collection, but it's there, it exists. So I am mentioning it here, okay, in order to address that. And then I also explained the process. I've already explained it to you before. Oh, I forgot to put the figure too. I put the title of the figure and I forgot to put the figure. I'll add that in later. This can be interesting as well. I haven't mentioned before, but the measurements are being done in units from the software. It's not like centimeters or inches or whatever it is. I am just writing this sentence to clarify that I know this and that it's not going to matter anyway because all the photos are measured in the same way. So what I'm doing is comparing them with each other. So here the results are in table 1. I've put a page break here so as not to allow my table to break across the pages. It looks really awful for organization when that happens. And notice that there is no source link in the bottom of this table, okay? And I also don't plan to put one on the bottom of figure 2, which is just going to be a screenshot from my iPad. The only one that required a source was the first one, which was images from a video that is not mine. So some students think that it's required to have some kind of source in everything. So sometimes I will see things like source typed by the author. This is absolutely unnecessary. You've just explained in the previous paragraph how you're collecting the data, and then there's a table, so it's obviously the data that you collected yourself. This doesn't require a source. This is not from a source. This is what you're doing. So the next step was to plot the data, which we can see in figure 3. It's going to be in the next page. As expected, the points form something periodic that fairly resembles a trigonometric function. But there was an unexpected difference. Between each period, there is an interval of time where the distance is very close to constant at 0. Re-examining the video, this clearly happens because although the spinning motion of her body is somewhat constant, the movement of her foot around her is clearly not. When her right foot gets close to her left knee, it stays there for a while before starting the next spin. This is reflection. This is the basic type of reflection for rubric D. Here's the figure that we were talking about. It is necessary to do this type of reflection, but it is the basic level. It's level 1, description of results. So you absolutely must do it, but you can't expect to receive a grade in 2 or 3 for reflection if all the type of reflection that you're doing is this kind of thing, okay? And it's fine, by the way. Not everybody needs to get a 20 on their IA. We just want to get this work out of the way. I find that the most difficult part of the IA for most students is to get started and to get it done, to have something to show. And maybe this intention to reach for the top mark in all of the rubrics is something that gets in the way because some of them are really difficult. By asking the software to fit the best possible sine function to the points, of course, the curve that fits the first set of points well does not work for the set of points for the second spin and vice versa, as illustrated in figures 4 and 5. So here is one of them, function f of x clearly fitting the first span, and then the second figure shows a function g of x clearly fitting the second span. And there is no hint of any calculator instructions of how I got the software to give me these curves, okay? This is most of the time not something that you want to include. No instructions, just results. But the results do need to come here. So I've mentioned functions f and g. I haven't typed them yet. So here they are. The functions that the software produced are f of x is this, g of x is this. Notice that they are both neatly typed using the equation editor from Google Docs. And here's a little bit more of reflection that is descriptive, but it's necessary to show that I know my math. So far, I haven't really done anything. I have typed some points and got a software to make a function for me. But I do want to show for rubric E, use of mathematics, I do want to show my understanding of trigonometric functions. So this is the kind of ways in which I can show it. As we can see, the coefficients of x inside of the sine functions are almost exactly the same, indicating that the functions have the same period. See what I did there? I showed that I know how to read the period of a function. But the second spin has a slightly larger amplitude and also a slightly lower principal axis. So I am showing that I know where to read these things in the function, and I'm at the same time showing that I know the vocabulary for these things, which is also good for B, mathematical communication. So don't let these opportunities go by. Use the words and say the things that you know. Indicating that on the second spin, as compared to the first one, the ballerina not only stretched out her leg more, but also more to the left of the camera, her right, at the point of the motion where the leg is most horizontal. Again, descriptive reflection. It is not just describing the mathematical functions, it is describing the functions in relation to the context where they're coming from, which is a good thing, but it's still descriptive. And now I'm going to start to have personal engagement, okay? Up until here, it was just the obvious things. Pause the video, type the points, ask for a curve, describe the curve. Now, there are multiple different ways in which I could choose to come up with one function to sort of fit both spins at the same time, because I don't want to have a different trigonometric function for each spin. I want one. For example, I could average out the amplitudes and the principal axis, since the periods are already the same. It would have been acceptable, okay? A lot of people do that kind of thing. The horizontal translation I will have to handle separately later, and this will be the real challenging part because there is nothing I can do to either of these functions to simply fill the pause between the spins. This is going to be the challenge in this IA, and I am acknowledging early that I am aware of that, but I will do the easy parts first. This is a good strategy. If I change the period to make it bigger, it would cover the pause, but it would make the function not fit the points. So I am not going to do that. And instead of the averaging out the parameters thing, what I'm choosing to do is to move the points of the second spin to the left to temporarily align them with the first spin so that I can get the best function to fit both. In everything except for horizontal translation, I think it is the third time in the text that I am making this observation, that I know that what I am doing does not account for horizontal translation. I am making it very clear that I am not just overlooking it. It is a choice, it is a strategy, and I am very aware of what I am doing. It's important to show that in the text for the person who is reading it and grading you. So here's a new function. It is age of x. The blue points are the first spin and the orange points are the second spin that has been shifted to the left by subtracting 3.28 from their x coordinate. Why 3.28? It was the distance between the first point that I measured on both spins. Little bit more of description. As expected, all of the parameters fall somewhere in between where they were in the previous functions. Now here's a little bit more deep reflection. This is maybe not entirely descriptive. I am aware that the first spin is contributing slightly more to the final function than the second spin because I measured more points from the first spin. Of course, I'm going to ignore that entirely, but I am commenting it because it is reflection. So I say this is a small limitation considering that both spins are so similar, so I will ignore it from now on. And then this next part, I admit it was kind of a weird choice for me to go into that at all. But what's bothering me more is that none of the functions that we've seen so far, that's f, g, and h, seem to go up quite as much as the highest points. And this is what I'm talking about. The software is fitting curves that don't go quite as high as I wanted them to. And the reason why I'm choosing to comment on this at all is that regression is weird. We've known this since the first linear regressions that we've done to calculate Pearson's correlation and whatnot. Regression is weird. Sometimes the function doesn't go through the points. And I don't want to go into that today, but particularly with trigonometric functions, I've seen GeoGebra do particularly weird things where he gives me a function that is clearly not the best for the points that I have. It's not the case here because this set of points was very nice. It was clearly doing this. So I knew that it wasn't going to give me something that was wildly wrong. But I have in other situations seen the same software for a different set of points give me wildly wrong answers. So I don't trust it 100%. I did not type anything about this in my IA because, again, I don't want to get into it today, maybe some other time. But I did comment on the maximum because for a different reason. Because I want to show my knowledge a little bit more. I want to show that that's for rubric E, again, use of mathematics, that I am able to change it by myself, that I know what I wanted to do. I wanted to be basically the same, but going a little bit higher. So I know what parameters to change in what way. This is me demonstrating my knowledge of mathematics. So I've changed it a little bit. See, I was able to do that. Now the red function is going a little bit higher up. I didn't change much on the lower points. How did I do that? I increased both the amplitude and the principal axis. By a little bit of trial and error, yes, but I knew where to look. So that's the only reason why I chose to work with P instead of H. So it is the one that I will be using from now on as I attempt to fix the issue with the pause between the spins. The easiest way to deal with this would be by using a piecewise function. Piecewise functions are so easy and simple things, but I see so many people be scared of them. I don't think that is justified at all. This would be the simplest way to handle this. The period of P is this, so I'm doing the 2 pi over b thing here, which again shows my mathematical knowledge. But we have already mentioned that the period of the function will actually want to be 3.28. This number 3.28 was used before as the distance between the first point on both spins. And I am calling that the period of the function that I want, even though it is not the period of this p of x function, which is just a sine function, because the function that I actually want is not a sine function. It starts out as a sine function and then it pauses. And then it does the same sine function again and pauses again. So this whole thing, including the pause, is also a periodic function. It's not a trigonometric function because trigonometric functions don't pause, but it is periodic and its period is 3.28. So I went to the graph, I measured the zeros, it's these numbers here. The middle one doesn't matter because it is this one here coming down. It's in the middle of the spin. But I am using the 15.02 and the 17.1 as parts of the domain in my piecewise function, okay? So I start with my P function. The third part is going to be a horizontal translation of the P function. And in the middle, I just have a 0 to make it horizontal there. Now, in my previous IA video, I mentioned that typing things with the thingy here on the left, that you can use ChatGPT to format this kind of image. You can just describe to her what you want to see on the screen. That is not what I did in this case. I used something a little bit prettier, but I just wanted to mention that ChatGPT is enough for this kind of thing. You don't have to learn a whole other thing. And this is what it looks like. It's exactly what it's supposed to be, right? It's a little bit of the p function, then constant at 0, and then another period of the p function. So this last paragraph is the last thing that I have written so far. It feels a little unsatisfying because we're trying to force the function into doing something that it does not want to do. Like I said, the piecewise function is the easiest way to do this. It's not necessarily the most satisfying way to do it or the best way to do it, okay? So the sharp corners at these numbers are also bothering me. These sharp corners here and here are points where the q of x function are not differentiable. I should type that sentence. It shows that I know another fun mathematical word. But the rest of this video is going to be me trying to figure out a better function to do this, okay? And you absolutely do not have to do this. You could wrap up the IA right here, write a concluding paragraph, and it would be good in terms of the rubric. Maybe you wouldn't get 4 for rubric A because of this initial thing here. If your teacher wanted to be really strict, she could choose not to condone that and just give you a 2 in presentation. But for mathematical communication, I have good graphs that explain what they are. I have well-typed functions. I am using vocabulary correctly, so I definitely get a 4 there. I don't like giving out 3s for personal engagement, but I could give a 2 for this one for things like deciding to put the 2 spins together in this way, deciding to move the local maximum up a little bit, deciding to use a piecewise function even. So we are at 8 points so far. I think I would also give 2 for reflection, again, because I don't like to give 3s. So we have 10 points. And for use of mathematics in SL, what sort of understanding did we demonstrate here? Limited, some, good, and thorough. I think it was good, so that's a 5 out of 6. So this is a 15 out of 20 IA. Even with the strictest of markings, this is good. You don't have to do too much. But I am, of course, going to do more right now just because I want to, and because I want to also address the E rubric use of mathematics for higher level, okay? Because they want rigor and sophistication. I usually skip over these parts and just throw away these 2 points. But this time I do want to do something that is a little bit sophisticated in order to handle this function here, okay? I am not going to be satisfied with the piecewise function. I am going to do something else. It's going to be sophisticated, and it's going to bring my rubric E to a 5 as well for high level. It's not going to be rigor and sophistication. It's going to be just the sophistication. Okay, so here's what's going to happen. We are going to think about composite functions and graphic transformations. More specifically, we're going to think about horizontal stretches, okay? So you know that the function sine of x gets smaller when you do sine of 2x. There's a whole thing with the horizontal axis doing everything backwards as to what you expect it to do. I have also a video about that. But for today, we are taking this for granted, right? If it was x over 2, then the function gets bigger. But today, I don't want you to just think of these things as graphic transformation, horizontal stretch, simple like that. I do want you to think about this as a composite function that has the sine of x on the outside and the 2x on the inside, or the x over 2. Of course, these 2 functions are lines. 2x has a bigger slope than x over 2. And that is basically what's going on. 2x makes the function go around faster because it's faster. It has a bigger slope, right? The other one is going slower with a smaller slope. So when you put that inside of the sine function, that makes the sine function go slower, which is what makes it look bigger, like it's been stretched. And when you understand things like that, you can start to do other different composite functions which are not in the syllabus, in the sense that, of course, any composite function is in the syllabus if you're only going to handle it algebraically. But understanding the graphical effect of a composite function that is not just a linear function on the inside, that is not in the syllabus. That doesn't stop us exploring what happens with that. For example, x to the power of 2 is not a linear function. X to the power of 2 starts out very slow and then it goes faster and faster. So what do we think should happen if I type in sine of x squared? What the 2x and the x over 2 examples are teaching us is that when the slope of the function is small, it goes slower. And when it's a big slope, it's going to go faster. So in the case of x squared, which starts with a small slope and then gets bigger, I think it's going to start by going slower and then it's going to speed up. And that's exactly what sine of x squared does. Look, it speeds up more and more and more the more you go to the right. This is not a periodic function, okay? You could ask for other things. What about 1 over x? 1 over x is the opposite. It starts with a very steep slope and then it goes down. The slopes in this example are negative because the 1 over x function is decreasing. But it's not going to matter because the outside function of our composite is a sine function, which is all periodic. So when we're looking at a decreasing function inside of the composite, all that matters is that we're moving to the left in the sine function instead of to the right. But visually, that doesn't matter. It's going to look exactly the same. So sine of 1 over x is kind of the opposite of the sine of x squared, right? Because the slope is getting very small in the end, so the function is slowing down. You can see that it's not even oscillating anymore as you go to the right. It's just flattening out. And over here in the middle, something very bizarre is happening. It is speeding up more and more, but because the slope of that function is going to infinity, right? 1 over x has a vertical asymptote. So it wants to go infinitely fast, which means that if you open it up like this, you can still see some of it going faster and faster, but at some point you stop seeing them. It just looks like a painted area because it's going so fast. Another interesting example that the most curious students sometimes ask, like, what does it look like when we start doing composite functions algebraically, right? So for example, sine of cosine of x. What does that look like? Well, it looks periodic, but you see how it's differently periodic? It's more rounded on the top than the usual sine function is. Also, its maximum is not quite at 1, because what's happening in this case is that you kind of have to think about domain and range of the inside function and the outside function of the composition. So with the cosine inside, cosine only goes between -1 and 1 for range. So the numbers that are going inside of the sine function are only numbers between -1 and 1. So between these two vertical lines here, so the outside function keeps going back and forth between these 2 points. And that's the value of the function. It's not quite -1 here. It's not quite 1 there. So that's what the blue function is doing, which is sine of cosine of x. So here is another interesting example. I am going to start with sine of 10x for my outside function because it oscillates kind of fast. But what I wanted to do is that I don't want it to oscillate forever. I wanted to do a little bit of its thing here and then level out on both ends. So my question is, what do I want to put inside of it for that to happen? The answer is that around the middle, I want something that looks pretty much just like y equals x, because if you put just x inside of a composite function, it's the same thing as not doing anything, right? So around the middle, I want it to just look basically like x, so that the outside function is going to continue to doing what it's doing. But then after that, I wanted to level out two asymptotes, which are horizontal, so that if that is happening in the inside function, the outside function is going to stop moving as well. So the question here is, what function do we know that does that? Starts with an asymptote, comes back up, and then flattens out again. Yes, arctangent. So there you go, sine of tan, arctangent of x. Look, it's kind of exactly what I was describing. It oscillates in the middle and then it levels out. It has a last local maximum here, and then it's going to go down again, but very, very slowly. Where is that horizontal asymptote going to be? Well, you have to think of domain and range again. Inside, we have arctangent, which was going to pi over 2. And then it's multiplied by 10, so that is 5 pi. That is where the sine wants to go to, the sine of 5 pi, which is 0. So this purple function here is going to have 0 asymptotes on both ends. So I hope that was enough examples to explain the kind of thing that I'm thinking about. Let's go back to thinking now about our function to see if we can do the one that we actually want, okay? So what we want is something that oscillates and then pauses, and then oscillates and then pauses, and does that periodically, right? So what do we need from our inside function of the composition for that to happen? We need for it to be increasing and then pausing, and then increasing and then pausing. So it's like increasing line and then horizontal line, increasing line, horizontal line. Do you know any function that does anything sort of like that? If you start from the sine function itself, you know that the derivative is kind of like 1 here and kind of like -1 here. So again, 1 and -1 and periodically. So if you add that to x, it becomes 2, 0, 2, 0, 2, 0 instead of 1, -1, 1, -1, and so on. That is the function that I am thinking about, that sort of thing, right? Of course, I'm going to have to adjust parameters, but something that goes up and then pauses, up and pauses. That's going to be the inside function for my composite function that I want for the ballet. If I use the sine of 10x as an example here, as an outside function, this is kind of what's happening, right? It's doing its thing and then pausing, doing its thing and then pausing. I'm just going to have to adjust the parameters so that it does exactly one loop and then pauses, and then one loop and then pauses. Okay, so here are some numbers that I want to write down. 15.02 is where I wanted to start going up. And then at 18.3, which is the beginning of the second loop, it's already started going up and stopped going up and paused, and I wanted to start going up again. But then I don't want it to look like P of 18.3, because that is not the period of P. The period of P is smaller. So I want it to look like P of 17.1, which is where it would naturally have started going up again. But I want to make it wait and then only start going up at 18.3. So what I'm going to need is a function that is sort of like sine of x plus x, but I'm going to stretch it and move it around so that it not only goes through those 2 points A and B that are just the numbers that I just said, but it does so in kind of the way that I just described, right? Which is like start going up here, and then at some point you're going to pause and start going up again there. This is what I wanted to do. Okay, so now let's see the results. I have a bunch of different functions because I didn't want to do all of the graphic transformations at the same time, because that would be confusing. So I started with just sine of x plus x, which I called t. And then for s, I did the horizontal stretch and the vertical stretch required on t for the periods. So remember, we have two different periods here. One in the horizontal, which is 328, is the period of the function that I want, which is what the 2 pi over 3.28 is doing there. And on the vertical side, we have a different period, which is of the original p of x function. Because vertically, as we move from point A to point B, we're not supposed to be moving 3.28, but only 2.09. So that's what this other factor of vertical stretch is doing outside here. And notice that it's upside down because of the difference in how the horizontal and vertical axis handle stretches. So after the stretching, the function already has the correct size, but it's not necessarily going through the points. So this other function v here is just the vertical translation. I subtracted wherever it was on 15.02 and then added 15.02 because that's point A, it's 1515. So this is the result, the same kind of function, but now passing through points A and B. So there was no guarantee that after I did the stretches and the vertical translation, of course it would pass through both points, but that was intentional. But it wasn't guaranteed that it would pass starting on the going up. It could have been anything. Point A could have been in the middle of the going up, for example, or in the beginning of the more horizontal part. As it turns out, however, it's not too bad. Point A is kind of in the beginning of the part where it goes up. I wish it was a little bit later, but this looked good enough to try already. And I still have a horizontal translation that I can make if it doesn't fit the points very well. So the picture that I'm showing you here is already with the horizontal translation that did turn out to be necessary. It was x plus 0.33, and it looks absolutely great. I am very, very satisfied with this result. At first glance, you could say that the horizontal part is not nearly as big as the one that we had with the piecewise function. But then again, look, it's passing through that point over there almost perfectly. And the same kind of thing is happening on the second spin. So I'll just mention one more thing about the 0.33 number, and then I'll tell you how you could try to improve this result. So 0.33 was basically trial and error. I looked at the picture without the horizontal translation and it was clearly shifted to the right. I could have just chosen a number visually, but instead I went back to the sign of x plus x and I tried to shift that to the left in order for the point A to be like closer to the beginning of the rise. So I put this orange line here, which is just the line y equals x. Remember, point A is on the line y equals x because it is 15.02 and 15.02. And that's what we want for the beginning of the spin, right? We want the function p of x to be just p of x and not p of something else, because at that part, it was doing the spin like we wanted to. So the closer that I can get my inside function to match y equals x at that part, the better. So I put y equals x in orange here in the picture and just chose the horizontal translation to get as close to that as possible, and it turned out to be 0.33. Notice that when I did that, the red function is not exactly going through the points A and B anymore. It is a very slight shift because 0.33 is such a small number, and there were ways that you could try to fix that in a different way. Basically, when I had a bunch of steps in building that function, you could have done the horizontal translation sooner. That's something that I don't want to think about right now, but if you want, as an exercise, I did the horizontal translation on V. So maybe if you did it in S or T, you could try to visually match it to y equals x in such a way that it still passes through both points. That is something that is worth exploring and exercising in case you want to build your skills in doing that kind of thing with functions. And the other thing that I would suggest if you want to make it even better is that when I remembered about the function sine of x plus x that goes up, horizontal, I didn't really try at all to say for how long it should go up and for how long it should be horizontal. I just allowed it to do whatever it wanted. And lucky for me, that turned out to be a very good result. But you see that the horizontal part is shorter than we wanted it to be. So maybe you could try to change the sine of x plus x function in some way so that you have control over the length of both types of parts. I didn't write this down in the file, but this would be my suggestion for further improvement, okay? Which is another thing on the rubric that sometimes people try to mention artificially, like an artificial way to make it better, but this is real. I would actually really like to see somebody else come up with an even better function to fit these points. So if you do that, please let me know. Just tell me the final result. What function does this even better than these?